Good morning to Dr. Ashikin and our fellow friends. Today our group will be presenting on wire and bar drawing. Introduction. Bar and wire drawings in metal forming are also known as a deformation process in which the workpiece is actually pushed through the convergent in a die form through a cylindrical bar or rod. The tensile test will be stressed all along. However, the material experiences and compressive stress will be inside the die, which will cause the plastic deformation to happen. A bar and rod diameter will be decreased in the drawing process, and the drawing typically will cause the cross-sectional area to decrease as well. The bolts and other hardwares are actually made from the drawn rods in the basic material. To create wires, the electrical lines, cables, and also strings, including the welding electrodes, wire drawing is utilized. The difference between the initial and ultimate diameters is also known as the drought. The metal forming process of the wire bar drawing is a pulling wire through continual rod and bars, which cannot be coiled. Hence, the drawing rods and bars will be into a tube, which will require the use of the drawbench.
Hello, my name is Li Han Chang, metric number AN200199, and now I will present the methodology parts of the project. So first of all, for wire drawing process, we need a wire. So here on the screen shows the modeling for the one of the wire models where 2 mm diameter of wire is reduced to 1 mm, and the reduction distance is 12 mm. Both the wire size diameter is modeled through the extrude boss from the SolidWorks functions, while the reduction length is from the revolve function. And the next part required for the wire drawing process is the wire drawing die. So from this figure is the sketch of the die for the wire process that we make in SolidWorks. So you can see the overall length of the die is longer than the reduction length from the wire. This is because for the wire cone surface to fit inside the die, it must be the contact surface must be bigger than the wire surface to prevent deformation on the biggest diameter size of the wire. So it won't deform when being pulled and stuck at the die inner surface of the die. Also from the sketch you can see there's an opening gap at the output side of the die. It is for better grabbing, better reaching of the wire with smaller diameter size. Also, it serves the purpose of cooling down and prevent the wire sticking on the inner surface of the die, because it will heat up a bit from the process when the wire is being pulled through the die. And from the left side we can see for the wire we use the plain carbon steel as the material for the wire, and then the die is the tool steel as material. And now I will pass to my teammates to expand about the discussion we made from this project.
Assalamualaikum warahmatullahi wabarakatuh. Then we proceed to discussion part. The first is wire drawing of 3mm and 4mm wire to the 1mm. So let we see at the picture. The 3mm wire is has stress 3.609 and the 4mm stress it have maximum 3.630. So the 3mm wire stress is lower than 4mm wire. It is because the 3mm surface area in contact is lower, and if it's lower, so the frictional force is lower too, because the area to make the force is lowest. The next part is wire drawing of 3mm and 4mm wire, but it is in the strand result. So the strand, let me see, 3mm wire, the strand is 1.304, and the 4mm wire, we get 1.343. So let me see this 3mm has a higher strength than 4mm wire. But this stimulation is maybe not at a good result, because if 4mm wire is much higher strength than 3mm wire, because the larger the diameter, uh, to the smaller diameter is require greater amount of strength. The next part is wire drawing apply in 500 Newton and 750 Newton. So let me see this. The 500 Newton, we get the maximum stress of 8.599, and the 750 Newton, we get the maximum stress is 1.290. So this means 500 Newton, it has lower stress than 750. This is because according to the formula of stress, is stress equal to force divided by area. So when the force is higher, the stress is also higher. When the area is higher, the stress is low. So in this case, the force is higher and the stress will become higher too. So the next one is about the strain part. So the 500 Newton, the strain part maximum is 3.266, and the 750 Newton, the maximum strength is 4.900. So which means the strength at 500 Newton is lower than 750 Newton. The strength of wire will affect by the drawing force. So the drawing force when higher, so the strength is also higher. Okay, on the next part, stress and strain between the flat fixed die and the two fixed die. So let me see this. We have four picture. Okay, the table show the value that I said the last previous slide. So let me see the fixed flat fixed and the two fixed is not make a different value, bit with different value, and the impact of stress and strain is lower, because maybe the bearing surface at the same area, because the wire drawing is to do the wire at the from bigger to the 1mm output. So it's same, so this if the same output, so the stress and strain value is still same, but not in the big difference.
Next, I'll talk about the recommendation done throughout the project. The recommendation for our project will be optimizing the processing parameters. The variation of process parameters throughout the functional coefficient, die geometry, drawing geometry can affect the drawing stress and temperature during the wire drawing. It is also help to achieve the decreased properties and also minimize the effects. Next will be the use of lubrication. Lubrication can reduce the friction during the wire drawing. Next, it also helps to improve the surface finish and reduce the ink of the defects. Lastly, it helps to improve the quality of the wire drawing. The last recommendation will be monitoring the drawing force. This helps to ensure the process is operating within the given limits. Next, it is also to help identify defects and also messes throughout the process. And lastly, it helps to improve the quality consistency of the resulting wire drawing. Thank you.